Okay. While I was on the break, I thought of how I could solve this problem really quick. So um, we um, we can't use this nice pre-built function for a remove. Well, we could if we figured some things out, maybe. But what we could do, what I'm going to do for now, is I'll just leave that there for a second. What we could do is actually do it in a loop. Okay, we haven't done that for a little while, back when we were doing JavaScript stuff. But there is a jQuery function called each. So let's just bring that back up here real quick. Each, jQuery, each. So what it does is it loops through a bunch of values. So we can loop through all of the values in averaged. So we could do that. We don't want to alert because that'll be annoying. So I'm going to change this to console.log. And I'm going to loop through each of the values in averaged, because average is just a feature collection. And I'm just going to console the value for now. So I'm going to run this. Here are each of the values. So this is 101. Oh, wait, just a second here. So averaged actually isn't an array, but it does have an array associated with it. So let me get that first. So I'm going to do console.log averaged to get the entire feature collection. So that's an object. So it's called features. Averaged dot features will give us all of the features. So now inside this log, each feature will be the value. If I refresh it, I'll just get a big old list of all the features. Okay. So in order to kind of replicate this behavior of removing the ones, what I can do is assign them a different value for the properties. So what I can do is say something like this: value dot, what's it called? Properties dot magnitude average. Don't want it in quotes. Do this if that equals number dot nan. I think that's the way they wanted it. For now, I'm just going to console.log just to see if it works. So what I'm doing here is going through each value and seeing if the magnitude average is not a number. I'm missing a each. Somewhere in here, I'm missing a. Oh, there it is. I didn't close that one up. Hey, it still doesn't show up here. Number dot not Doesn't get any easier trying to figure out what not a number is. Okay, NaN. Let's try one more time. Check for NaN JavaScript. Is NaN. Let's try this. So this is saying if it's an NaN, then console.log the value, which right now is just NaN. Yep, okay, that worked. All right, so now what I want to do is assign it some other value in order to, I wanted to assign it some other value in order to get the remove function to work correctly. So what I can do is say, if it does equal NaN, let's assign it a new value that's equal to -1. Now, why is -1 going to work? Well, there are no negative values for the average earthquake value. So I could really use any negative number. So what I'm doing is assigning all of the values that were NaN, I'm assigning them the value of -1. So then what I can do is remove only those values that have a -1 value, and I'll be able to get a better representation of the first third, the second third, and the final third of only those states that have values, earthquakes in them. There we go. So that worked a little bit better. So the average, the state with the highest average earthquake value appears to be Montana with a 3.06. Oh, sorry, Alaska 3.0519. Well, okay, so it's in the same category, but it's just as high. All of these guys have a value of -1. Why weren't they removed? They should have been removed. Yeah. They should have been removed, but they weren't. Interesting. But Idaho was removed. It does have a value of 3.18. That's just weird. That's the very highest value. So maybe if I did this. Oh, I know what we have to do here. Because we still didn't use the state filtered on the map. We used the average on the map. So we're displaying the average instead of the state filtered. There we go. So now we have only those states that have earthquakes in them. Now we are doing some logic here that's not right. Idaho should be red, but that's probably because we're choosing. Yep, there we go. So we just had a greater than or equal to logic in our logic. So we've just eliminated all of the states that don't have not a number, and now our high, medium, low values make more sense. Roughly a third of our states are in the high category. Roughly a third of our states are in the medium, and we only have one in the low category. Not sure. It should be like 221, but we could examine our logic a little bit further to find out why that is. We only have one state in that low category. But in any case, we've gotten it to where I thought it should have been, and we had to run this each command in order to do that and change our code a little bit. So what I'm going to do is actually save this as week 11 final example. Okay. All right, and then I'll upload that onto Blackboard. Actually, I'll just go ahead and do it right now. Edit. And then what we'll do for the lab portion of the course today is I'll walk through what I would like you to do with my data or with some example data, what you should do for the lab. Okay, so I'm just going to upload this and submit. Okay, so what I would like you to do is once you've published some data, it looks like Heather has some data published on here, and what I can do is help any of you other students publish some data that haven't published data yet onto here, or actually onto ArcGIS. You can also get GeoJSON from ArcGIS if you want to do it through that. But what I want you to do is take some of this data and perform a turf function on the data. I'm not going to be specific on which one you would do, but you can do whichever one you want. So for an example, I'm going to take these Manhattan, New York points of interest. I think this is one of the default layers that are already on there. And if we look in the open layers, we've got fire, locks, art, stock, church. I'm going to take these layers and I'm going to do something with turf.js to do something. I could buffer all of them, or I could actually let the user specify which one they wanted me to zoom in on, something like that. But let's do one of those examples. So in order to do that, I'm going to get the GeoJSON for this layer. I'm going to get the GeoJSON link for that layer, which is under GeoJSON P. So now I've got the feature collection for those. So once you build your layer, I get the GeoJSON link just the way I got it. Okay. All right. It might be easiest to start from the example from the previous week where we actually utilized that. Let's pull that up. Okay, so from the previous week where we have the leaflet example, I'm going to start from that one. We did have, now what was the one where did we actually add it to the map in class or no? Let me see. So I'm downloading the one from last week's class. Of course, I've already downloaded it. And I'm going to look and see if we added it to the map. No, I guess oh yeah, right there. Handle JSON. Which layer is this? Oh, I might have deleted that layer. To like make room for other layers. That probably wasn't a good idea. Let me look here. New Windows open. GeoServer. See if it's still there. George, New York City roads. Is that the one? Interstates Raber. Interstates Raber. No, it's still there. Is it showing up on the map though? Sorry. Should have gotten this together during the break. Okay.
It is showing on the map. It just takes a little bit.
Oh, that's right, because it's kind of a bigger layer. I'm just trying to bring it up. I'm going to go ahead and save this as week 11. So I'm just saving this as week 11 example. Week 11 underscore example. All right, so all of the lines should show up. Yeah, there they go. Thank you. So they just take a few seconds. So we could buffer this layer or do something to this layer, but it's such a big layer that I'm gonna concentrate more on this other layer in just the Manhattan area. So what I'm going to do is change these parameters so that I'm loading that layer. So if I go back to here and I get the here's the GeoJSON data. Okay, so I'm going to take these parameters and modify this code so that I get that data. So instead of being HTTP GeoServer Raber OWS, it's GeoServer Tiger. So I got to change Raber to Tiger. Oops. That's not what I meant to do. I meant to just paste. Okay. And then here under Raber Interstates Raber, I got to change that code right here to Tiger POI, which stands for Tiger Points of Interest. Right there. Everything else should be nothing that I need to change. For now, we'll just let it pick a black and yellow fill color. We'll see if we can make the dot a little bit larger. 3. That should work. Oh, so the layer dot popup is going to be bound to feature.properties.route number. That's probably not going to work. So for now, I'm just going to uncomment out that line just because feature.property.route number doesn't exist. So now if I refresh this page, I'm going to get those data that show up in Manhattan area. Oops. And in fact, we might want to start off in that area. What I'm going to do here is look at the geometry for this point. Oops, the geometry. And I'm going to take the coordinates. And I will have this example. I will post this example up there. I'm going to take the coordinates and recenter the map so that it starts there. and I'll go to like level 16. Oops, 16. And restart that map. Okay, so now, oh, maybe not 16. 14. There we go. There's still one more up there, yeah. So maybe 13. That looks good. Okay, so now I've got all those points, but I don't have a pop-up bound to them. So let's look and see what what properties I can add to those pop-up. So it looks like the name is probably what I want. So now I'll say features.properties.name, all caps, and then uncomment this out. So now I'll have a property, I'll have a pop-up bound to that. Now I hit this button, oops, after I refresh. I hit this button, it'll tell me that's fire, that's locks, stock, art, so on. Okay. I've actually got to style this using the other function, but I'm not going to worry about the style for now. We're worried about turf this week. If I wanted to style this, I got to style it using the I've got to use it. I've got to style it using the function called point to layer, and creating a circle marker. So if we want to style those, that's how we have to do that. Okay. So what turf function should we use? Does anybody have an opinion? What kind of turf function you want me to do as an example? We could buffer them. We haven't buffered anything yet. That might be good. In fact, let's do two. Let's practice doing another filter and then a buffer, anything that matches the filter. Okay. So here is where it ends. Okay. Yep, that's where it ends. And here's the map. Okay. And so we're going to go down below where the map is created, down here, and we're going to add in code to, actually, no, let's not do it there. You know, I don't know why this works, because this adds it to the map up here. Oh, actually, I know why it works. This function doesn't actually run until after the map is loaded. Okay, let's add it in right here, but at this point. So what happens here is that when the JSON data is loaded, it's going to run this function. And that function is just going to add the raw points to the map. And we're going to add in filter points here, and then buffer points here, and add to map. Okay, we're going to do those two things. So let's first work on filtering our points. Oh, and by the way, we do have to change this. Like I said before, this Turf version 3 doesn't have the abilities that Turf version 2 has yet. It's more broken. So go to the other example and copy Turf version 2's code up into there. So now I have Turf version 2, which is more complete, and it should work. Okay, so let's filter. Filter by saying turf dot filter, and to filter the values, we can find, we first have to give it the name of the features. Okay, that's data. Data is all the features. And then we have to give it, what else do we have to give it? Let's go look at the example. That's always helpful. Oh. So after we give it the features, there's the example here, the features, we need to give it the name of the field that we're trying to filter on, which in this case is name. And for now, let's change this so that we'll just hard code it. So for name, we'll have a value of, what was one of the values? Fire station. So we're going to find all the areas that are within a certain distance of a fire station. So we also have to feed in an output name. So turf, filter, we'll just call it filtered. So this is the new data set that gets created. So filtered is now going to have the results of this filter operation. And in fact, the first thing I think we should do is make sure that that works, get the filtered values, and display them. So there should be just one object, and there is. And that one object should be the fire. So we go to properties, name, fire. Okay. If we changed that to art or to locks, we would get the art or the locks place. Right? Okay. So that worked. Now we just need to buffer this filtered data set and add it to the map. So let's look for the help for buffered. Buffer is right here. And so we're going to go down. And we're going to go to turf.buffer right here. It looks like it's asking us to put in the name of the features to buffer, the variable name, a distance, and then units, miles. It's pretty cool that it'll allow us to do that. I'm going to just copy that code and put it right here. So var buffer equals turf.buffer. We've got to change FC to what? We want to buffer the filtered data set. So what should we change this to? Yeah, filtered. Good. Okay, and 100 miles is probably ridiculous. Let's just do 10 miles. Okay, so now it's going to buffer that, and then look, there's already some code for adding this to the map. So let's just do that. Oh, but is this leaflet code? Let's just see if it works. I don't think this is actually leaflet code. Yeah, that's leaflet. Buffer.set GeoJSON buffer. That's not adding it to the map though. That's going to add it to the map. Just copy all that code in there. Got to create that buffered layer. Oh, that does require a map box. It's a different library. Okay. Never mind. So we're going to have to add this. We're going to have to add this GeoJSON to the data, to the map, the same way we add any GeoJSON data to the map. So copy this data and add we're going to add, instead of buffer, we're going to add, instead of data, we're going to make it say buffer. I'm going to call it buffered. So now it's going to take the buffer data and it's going to add this to the map. And this style should work. Okay, so 10 miles is still pretty far. I wonder if we can change, I wonder what units it'll accept. That'd be kind of cool. Let's see if it'll accept meters. It doesn't look like it likes meters unless it's really small. Maybe, yeah, that's there. Okay, so let's do 1 kilometer. Okay, so that's a 1 kilometer buffer around the fire station. And why does it look like that? What would you expect a buffer to look like normally? Is that correct or incorrect? What do you think?
What?
It looks weird. I'll tell you that it's correct. How could it be correct? What projection is it using? What's that? Web Mercator, right? And if you think about Web Mercator, as you go further north, you're stretching out latitude differently than you're stretching out longitude. And so it's actually correcting for that on the fly. So it's kind of cool. So that really is 1 kilometer away from that fire station. It's a shorter distance in X than it is in Y because of the distortion that the map is presenting. So, one of the things that's kind of cool is that this turf.js is actually calculating that error in the map projection for you and showing that. That's a lot of code is what I'm trying to get at. Although we were able to code the filtered pretty well, even just as a function, you could probably write something that way. It would be harder to program this function that would do a buffer based on a distance like that. Okay. Now, we could add a text box in here, right? We could put a button like we've done in the past, add a text box, so that if the user typed fire, then it would buffer the fire. In fact, we could add 2 text boxes. One text box that was the buffer distance, and one text box that was one text box that was the name of the field. Like you could actually give them options: fire, church, locks, and they could drop down, and you could have them buffer different ones of those. Additionally, we could take this even further, where we could take the output of this buffer data set and use it to tag any of the other data. In other words, we could ask a question now: what other features are within, in this case, 1 kilometer of this fire station? Right now, it doesn't look like there's any. Let's change this slightly. Okay, so I'm going to change this to 1500 and see what happens. Bam. Okay. I'll change it to 1300. Okay, so now look, this locks is inside of that polygon. What we could do, I won't add this to the map, I'll just do it as a console log. What we could do is we could tag again. Turf.tag. Just going to copy that code right here. We can tag the points, the original input points, which were called data. We could tag them with buffered, and we could tag them with the, let's see if we get that attribute coming through. Oh, that's not there. Well, we'd first probably want to assign an attribute to this buffer. See if there's another turf function that just does inside. There we go. That's it. Check to see if a point is inside of a polygon. That's what we want. So tag would work, but we'd have to first assign an attribute in order to get tagged. So tag is like a two-step process. But this one here, turf dot inside should work instead. Turf dot inside polygon would be buffered. Point would be point would be data. Actually, this doesn't look like it's going to work. Get an error? Yeah. Okay. So that doesn't work because this deals with individual points and individual polygons rather than feature collections. So I guess the only way to do this would be to tag it, to use tag. In order to do that, what we would do is first assign the items in buffer an attribute that was unique. Like we could say our buffer, and then we could then tag the polygons, the points with that feature value to do that. Something like this. Let me get the code here. So something like this, where we would say, there we go, each okay. So what this is going to do is it's going to take each buffer, there's only going to be one because we're only buffering one feature, and it's going to assign a new field called buffer, and it's going to assign a value true if it is within the buffer. I think I'm just going to do 1 because that'll be easier. Okay? And then what I could do is tag based on that attribute. Say turf.tag the points, which our points are called data, and our polygon features are called buffered. And we're going to take buffer and marker color. Oh, that's the name of the field. We'll call it buffer. We'll call it buffer even on the other one. Okay, so now when I refresh this page, if I look at this point right here. Well, I don't have those points, but let's log them so I can console.log tagged. There we go. So now I've logged the tagged features, and if I look at the properties of the feature, buffer is 1 because it was buffered. And then I could highlight that. I could show that a particular one as a different color or whatnot. All right. So the point is, you can take each of these functions that are available inside of turf.js and chain them together just like you would chain together tools in a toolbox to perform an operation. So you could do a spatial join and then a buffer in order to find the distance, everything that was in a certain distance of a certain object. So your assignment is to take your data, load it in, and utilize turf to make it do something like this. You don't have to do a buffer. You could do a filter. You could do anything in the list. You could explore and do something different. You could create, you could do an erase. You could do an envelope. Envelope is kind of cool. All it does is it creates a box around the maximum extent of all the features that you give it. So this is the dark box is the envelope around all the features. So there's a bunch of points and there's two polygons. All right, so I think it's 7 o'clock. We'll go ahead and end there. And Elida, if you want, you could for sure take off, and then we can meet up sometime later this week if you have questions, and then I can help the students here. Does that sound good?
Yeah, that sounds good.
Okay. All right, I'm going to stop recording.